Hi everyone, I am Sandesh and I am presenting my project Liquid Level Monitoring System. There are different areas where liquid level has to be monitored, like in houses or industries. Manual monitoring of liquid is very inefficient because a person has to go to the location where the container is placed every time liquid level has to be monitored. Also, sometimes the container is placed in some dangerous areas, like in the top of the house, which can cause serious accident. Besides that, there might be some harmful chemical inside the container which can cause serious health hazards. So the solution is liquid level monitoring system using IoT. This system monitors the level of liquid in a container and sends the data to the server. So the user can view the level of liquid from the remote location using their mobile phones. So here is the system design. The Android device sends the HTTP request to the Raspberry Pi Python server. Raspberry Pi Python server receives the request and requests Raspberry Pi for the depth of the liquid from the top of the container. After getting depth of the liquid from top of the ultrasonic sensor, from the Raspberry Pi sends the data to the Raspberry Pi Python server. Finally, the Raspberry Pi Python server sends the response to the Android device. So here are the software programming languages that are used to develop this system. Android Studio was used as IDE to develop Android application. Android SDK contains tools libraries to develop Android application. Java was used as a programming language to develop Android application. Only Python IDE was used to write Python code on Raspberry Pi. Python was used as a programming language to code Raspberry Pi. So the list of hardwares used are Raspberry Pi Model 3B, which was used to run the Python server and get the data from ultrasonic sensor. Ultrasonic sensor HCSR04 was used to measure the depth of liquid from the top of the container. Jumper wires were used to connect Raspberry Pi and ultrasonic sensor. Bucket contains water, which liquid level has to be monitored, and Android simulator was used in place of Android phone. When the user launches the main activity, the main UI of the application shows up. So to get the liquid level, user has to press get liquid level button. After that, main activity calls the do in background method of another class which runs in background. All the HTTP request response cycle is completed in the background. So that background method sends the HTTP request to Raspberry Pi Python server, and when it gets back the response, it calls a callback method of main activity. That callback method changes the UI of main activity and user can see the level of liquid in the container. So this is the screenshot of Android application code. So the client class, as you can see, contains do in background method. Hence, when the button is clicked, object of client class is created and execute method is called, which ensures that do in background method is executed. Also, you can see that main activity implements my callback and my callback interface, which my callback interface contains callback method. So this is the backend of the application. A server is started with an IP address and port number. When it receives a request from Android application, it gets the depth of the liquid from the ultrasonic sensor. Finally, the ultrasonic sensor gets the response back from the server. So this is the logic to measure distance using ultrasonic sensor. So start time and end time are the times the ultrasonic sensor sends the ultrasonic sound wave inside the container and gets the ultrasonic wave back. So the total time taken to travel ultrasonic wave from top of the container to liquid level and back to the top is noted. Finally, the distance is measured by multiplying the total time taken and the speed of ultrasonic wave divided by 2, since it has to travel from top to the liquid level and back to the top. Now let's see the demo. As you can see, there's some water in the container right now, so let's see how much percentage of the container is filled with water. So let's run the project. So let's get the liquid level. So 46% of the container is currently filled with water, so let's pour some more water in the container. Now Let's get the liquid level again. So now 61% of the container is filled with water. So let's pour some more water in the container. And now the container is almost full. Let's see the liquid level now. Okay, the liquid level is almost full. So 84% of the container is currently filled with water now.